Hopefully those first three questions seemed reasonable to you. Is that true? Maybe that fourth one kind of tripped you up a little bit. So again, we've got the first question. What is the system's acceleration? It says before the system is moving. 0. Yes, it is. No movement means no acceleration. What is the system's net force? 0. Why is it 0? I didn't hear a resounding answer for that. How do you know the net force is 0? Yeah. Yeah. I'm going to write it out the other way, but it's the same thing. Acceleration is F net. Oh, I guess yeah, you're right. I should write it the other way. That would make more sense for you guys, wouldn't it? F net. Seriously, come on. This thing needs to be replaced. Equals MA. If the acceleration is 0, 0 times anything is 0. So there you go. All right. Number 3. How does the applied force compare to the frictional force? They have to be the same, don't they? Yeah. Same magnitude. Same direction also? No, opposite direction. And then question number 4 is something you haven't seen yet before. This is like the introduction to it, right? The frictional force acting is called, hey, did you know there are 2 kinds of friction? What? We've just been talking about friction as though it's just this thing. But really there are 2 kinds. Friction kind number 1 is static and number 2 is kinetic. Have you heard either of those words, static or kinetic, before? Yeah. Where have you heard the word kinetic before? Do you know? What'd you say? In motion. In motion? I heard somebody else say something too. The sand. The sand. Kinetic sand. Have you ever played with it? It's like, right? It's a thing. And what's so nice? You can move it, right? You move it through your fingers. So the word kinetic does mean in motion. Have you heard the word static before, friends? Where have you heard static? Literally, like on the radio? Or like, where else have you heard of the word static? When you shock your friends, right? We're getting into that time of year where static electricity is totally a thing. Static electricity is called that because you build up a bunch of electrons and they just sit there until, right? Okay? Static means at rest. So now, given that information, given those 2 definitions, the frictional force acting in this case before the system is moving is what kind of friction, friends? It is indeed static. Hey, do you see that there's another set of 4 questions? They're right there. Once the system is moving, if the system's moving at a constant speed, what's the acceleration? What's the net force? Can you answer these questions for me? Go. Go ahead and do that. I'll give you just a minute. Hey, physicists. I love this set of questions because it kind of makes you think. And that's what my job is, right? So I get paid the big bucks to do is to make you think. So here's the situation. Stay with me, my dears. Once the system is moving, if it's moving at a, what does that say? Constant speed. Hey, then that first question should be pretty darn easy. What is the system's acceleration? 0. Oh, that was nice. It was kind of almost like loud. Like not really, but maybe we can try even more on the next question. Oops, it's frozen, so you can't see my enthusiastic 0. Why is it 0? Why is the acceleration 0? Constant speed, no acceleration, right? All right, now let's think about it. Now the object is moving, right? The object is moving at a constant speed. What is the system's net force? 0. It is, for sure. Same reason. You did miss it. It was kind of too bad. That's okay. Yeah. Same reason, right? F net equals MA. If A is 0, F is 0. Bam, you're done. Okay? Next question. How does the applied force compare to the frictional force? The applied force is a larger magnitude? Yeah, do you guys agree? So if we draw that free body diagram, and you've got an applied force this way, and you've got a friction force this way, is that going to result in a net force of 0?
No.
It is not. A lot of people think this is right. This is why we're doing these questions, right? To make sure we're thinking about it. How does the applied force compare to the frictional force if the net force is 0?
Same.
They are the same in magnitude. They have to be. They have to be. Okay? Same magnitude. Same size. Tell me about the direction. Opposite, because they have to add up to what?
0.
Yes, they do. All right. Given what you know about the words static and kinetic now, the frictional force in this case is called what? Indeed it is, right? Good for you. Questions you have right now? Okay. There's a little thing on the bottom there. We're going to take a look at this. When I had this printed, I have this constant fight with Google Docs. Don't love Google Docs. A lot of people do. But this is what it was supposed to look like. So you're still on the front. There's a graph on the front that did not print the bottom axis. So go ahead and draw that bottom axis in for me. And I'm going to transfer over here to show you what your lab is going to look like today. Like this, like this. Switch this back over. Hope that it'll go. Yay, there it is. Okay, so the graph looks something like, it goes up, 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 up to a peak, and then it kind of fell and went something like that. Yeah? What are we graphing? Well, this is time. We like to have our axes labeled. And what do you think are the axis label on this side? Force, it is. So a couple things that I want you to mark. Here's the first one. This part right here is not moving. Okay. And this part over here is where it is moving, and it's moving at a constant speed. Come on. Okay. This peak right here, that is the maximum static friction. Okay. Your task for the day today, if you flip your sheet over, you'll see that the research question says, how does an object's mass affect the frictional force acting? So I want to know how adding mass to something affects the amount of frictional force that I have to apply, okay? It says, after reading the technical information, work with your group to develop a procedure, okay, in order to collect data to answer the question for both kinetic and static friction. Okay, so your data should include two frictional forces, both the kinetic, which is the flat line, and that peak, that static force. I'm not going to show you right now how to get the data because it will be too confusing. So when you're ready, you're going to raise your hand and we will show you where to do it. Okay, you're going to analyze the data and I'll show you that in a minute. Okay, create your data table on separate paper, one data table per person. You're going to be working in groups, but one data table per person, okay? There's a bunch of information here as to how to set it up, and once you've read through that, it'll make more sense, okay? You have got the next 22 minutes to collect data, okay? You and your partners need to determine how much data to collect, what data to collect, and all of those sorts of things, knowing that tomorrow we are going to analyze your data, okay? And by we, I mean you. We'll get to analyze your data. Okay, so you need to work efficiently and you need to work well, okay? I have 12 bins of stuff set up back there. Every bin has a label with exactly what's in there, and it needs to have the exact same amount of stuff and those things when you put it back, The only thing you need to provide is a Chromebook, 1 per group. Okay? You may work in groups of 2 or 3, and I'm going to allow you to pick your groups so that you can work efficiently. Okay? Go ahead and get started.
Could you do me the honor? I suppose.